Hello and welcome to Unit 4 test review, which is graphing linear functions. So let's look at number 1. To find the slope from a graph, the easiest way is to find coordinates that have integer x's and y's, or if you're looking at that kind of cross through the graph lines, the grid lines that are right on a perfect grid line, like one of these coordinates would be great, or two of them. We need two of them. There's actually another one up here with this arrow, and then that's it. So you need to take two points. The closer ones, the better, because then you don't have to simplify. And we do the rise, which means up and down, up or down, whichever way. Up, you're going to say it's a positive number. Down is a negative number. So first we're going to go, so if I say, let's take these two coordinates here. I'm going to go down one. I always start on the left point. That way it's -1 is your numerator. Start on the left point. You're either going to go up or down first, and then that's the only positive or negative. Then you're always going to go right. Then we're going to go run. Run means right or left. Right is positive, left is negative. So we're going to go right 1, 2. That's +2. And then we don't have to simplify -1/2. That is your slope of that line. And the slope of the given graph. Again, let's find some coordinates. Does not matter. There's coordinates all the way along this line, everywhere. So pick 2 and do your rise or run. So I'm just going to pick these two right here. I'm going to go up and down 0. And I'm going to go right 1. 0 divided by 1 is 0. So the slope is 0. And think about this. You can walk on this line. Anytime you can walk on a line, if you're walking, it has this number for a slope. A vertical line does not. That's a vertical line would be undefined. Meaning you can't, there's no number that will give you that slope. All right. Now, when we have a slope, finding slope given two coordinates, now we don't have a graph, and you might have x or y values that are really big. So graphing it isn't really an easy option. So now for this, what you do, the slope, which is our m, is going to be y2 minus y1 over x2 minus x1. So we first label xy, xy, figure out which coordinate you want to be your first coordinate, so that's what the little subscripts are, which coordinate you want to be your second coordinate. So in graphing here, we have y2, let's put these in parentheses. y2 is -2 minus y1, which is 8. x2 is 19 minus x1 is 1. -2 minus 8 is a -10. 19 minus 1 is 18. We got to simplify this fraction. Divide them by 2. Let's start there. That's -5 over 9, and I cannot simplify that further. There's my slope, is -5/9. That is the slope, which is m. In y equals mx plus b. That's the slope. And this is the coefficient in front of the x. All right, again, we're given two coordinates. Finding the slope. Label your x, y's. Which one's going to be your first coordinate? Which one's going to be your second coordinate? Does not matter. We're going to do 0 minus 14 and -7 minus -7. So I have 0 minus 14 is -14. -7 minus a -7 is a plus. That'll end up being +7. -7 plus 7 is 0. -14 divided by 0. You can never divide by 0. This cannot happen in math. You cannot divide by 0. So that was undefined. There's no number that will give that you could simplify -14 divided by 0. So undefined slope. Number 5, finding the missing value here. We are going to set this up the exact same way. We're given two coordinates, and now we have actual slope. Now we have one of the coordinates has a missing y value, but we're going to treat this just the same. So just label xy, xy. which coordinate you want to be your first coordinate, label which one you want to be your second coordinate, and let's substitute into the slope formula. So y2 minus y1, which we don't know, x2 minus x1. And another thing we do know in this case, we know the slope, so this equals -4. Simplifying, we got -7 minus y. That nothing simplifies there, but we have 1 minus a negative. Opposite of a -3 is plus, so that's going to be 4 equals -4. Now, a while ago we learned about multiplying by or cross multiplying, so that's 1 times -7 minus y, and that's going to equal -4 times 4. And we can distribute the 1 in, but in distributing 1 doesn't change the value of anything. -4 times 4 is -16. And now we can solve a quick solve for y. So we have add 7. Those are like terms, -16 and 7. That's a -1 in front of the y. To get rid of it, you got to divide. And we get y equals 9. That is our missing value. All right. Let's do it again. Number 6. We have x, y, x, y. Which one's going to be your first coordinate? Which one's going to be your second coordinate? And let's start substituting in. So we have y2. I don't know what that is. Minus y1 over x2 minus x1 equals, we have the slope. The numerator, we can kind of simplify the minus a negative is a plus, the opposite of a negative is a positive. In the denominator, we have the same thing, minus a negative, which is a plus, so that's -5 plus 3, which is -2. And that equals 9/2, 9 over 2. Now we're going to cross multiply, so 2 times y plus 4, and -2 times -9. We're going to distribute the 2. 2 times y is 2y, 2 times 4 is 8. -2 times -9 is +18. Let's do a quick solve on this two-step equation. We're going to combine our like terms, constants, and divide by 2, and you get y equals 5. Now in number 5, we're going to graph. Oh, I guess my numbering is a little off. So we're going to graph. We have y equals mx plus b. And then when you see an equation in this form, first place you start is with the y-intercept, the b. This is the start. You start here. And we're on the y-axis, so we're looking right along the y-axis here. It's kind of a little off, but right on the y-axis. In this case, our y-intercept is -4. So we're going to go on the y-axis. We're going to go down to 1, 2, 3, -4, and put a point. That is our starting point. Starting coordinate. Now we also, then after that, we are going to use the slope to find another coordinate, another point. So the slope in this case is -3 over 2. So that means, or +3 over 2, sorry. We're going to go up 3 as a positive and right 2, rise over run. So from our y-intercept, we're going to go up 1, 2, 3, and we're going to go to the right 1, 2. We can continue that pattern. Instead of going up 3 and right 2, you could go down 3, we're off the graph, and left 2. So you can go the opposite direction. Make sure you draw your line. Oh my goodness, that is so wavy. And put some arrows on the end. Draw your line through all the coordinates and draw an arrow on the end. Number 6. What is our y-intercept? Our y-intercept is 0. And then what is our slope? Our slope is -1. So slope of -1, you're going to put that over 1. We're going to go down 1 and right 1. This means down is -1. And positive on the denominator means you're going to the right. So down and right, down and right, down and right, down 1 to right 1. You can also go up 1. So -1 over 1 is the same thing as 1 over -1. So this would be up and left. So you can go the opposite directions. Up 1, left 1. And we could have all these points, which when we connect them, will make a really nice straight line. If I could draw a straight line. That is why people use straight edges. All right, number 7, y equals 4. So this, you could write it into the y equals mx plus b, which means that your y-intercept is at 4. And then our slope is 0. Slope of 0 is a horizontal line. Or you can look at it as if your slope is 0, you can put that over 1, which means you're going up and down 0, and you go right 1. Up and down 0, go right 1. Up and down 0, go right 1. So you can use the actual slope for this. Another thing you could say for this point, so that where y equals 4, any coordinate, so this is 1, 4, over here is 3, 4, 0, 4. Any of these coordinates, the only thing you can really say about them is that the y value is 4, which is this, y equals 4. The y is always going to equal 4, and that's the only point that makes sense. All right, number 8. You can, if you want the equation in y equals slope-intercept form, you've got to realize that the slope is always the coefficient in front of the x. So if you want to switch it around, you certainly can. -2x, and this is a positive 5. That's your y-intercept. So we go up 5, and then we're going to go down 2 and right 1. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Cool. Draw your graph through, and we're done. You can always look at the slope. The slope of the graph is negative, and it's a negative number for a slope. All right, number 9. Remember, we have to get this in y equals mx plus b. The y has to be by itself. Let's not. This is 3 times y, so we have to divide by 3 on every term. So now we get the y by itself. It's 5/3 is your slope minus 2. So your y-intercept is -2. You go up 5, 1, 2, 3, 4, 5, and right 3. You could go down 5 and left 3. You're off the graph. But I like to try to have more than 2 points, but technically all you need is 2 coordinates to draw a line. And make sure you draw your line all the way through and put arrows on the end since they are a continuous function. All right, number 10. To graph here, I'm going to get it in y equals mx plus b form. You can graph by the x and y intercepts, but I'm going to subtract x first, get the x term over. I'm going to actually move this whole thing over. -2y equals, I'm going to write the x term first, and the 10 is positive, so plus 10. Divide by -2 on every term. Y equals a negative divided by negative is a positive. 10 divided by -2 is a -5. Now this is going to be a 1/2. 1's next to the x, so it's going to be 1/2 x minus 5. So our y-intercept is -5, and our slope is up 1, right 2. Or you can go down 1, left 2. And there's your graph. All right, number 11, find the x and y-intercepts from the following function. To find your x-intercept, you set y equal to 0. So it's going to be 2x plus 3, replace the y with 0 equals 48. 3 times 0 is 0. This is end up going to be 2x equals 48. Divide by 2, and we get the x is going to equal 24. That's your x-intercept. So we have 24 and 0 is your y. That's what our y is. To find your y-intercept, let me do this in green. Set our x equals 0. So -2 times 0 plus 3y equals 48. -2 times 0 is 0, plus 3y is 3y. Divide by 3, and the y is going to equal 16. So our x coordinate is 0, our y coordinate is 16. All right, find the x and y intercepts again. X-intercept, and set the y equal to 0. We have a negative x equals 11. The negative needs to move. That's negative 1. Divide by negative 1. And we have negative 11 as your x-intercept. For the y-intercept, we're going to set x equal to 0. So negative 0, which doesn't make sense. You can't have a negative 0, so that's just going to be 0 plus y is y. And it's already solved for. Y equals 11. So we have the x value is 0, the y value is 11. That's your y-intercept. All right, number 13. Given the following function, which has a steeper slope? I don't know by looking right now, so we need to solve for y. I'm going to subtract 5x. Subtract 5x. Those are not like terms. So I'm just going to write negative 5x plus 20 to get in mx plus b form. Divide by 4 on all terms. And we get y equals negative 5 force x plus 5. So we're talking about slope. So I'm just going to kind of highlight the slope here in front of the x. And then let's find the slope of our next equation. So I'm going to subtract 5x. Negative 5x minus 10. And here's the y equals. There's my slope. Which number would be greater, like give us steeper slope? Well, negative bottom equation. Negative 5 is going to be way bigger than negative 5 divided by 4, which is negative 1.25. I'd say negative 5 gives us steeper negative slope. All right, which one has a larger y-intercept? Well, this is the exact same problems. So to look at the y-intercept, so the top equation was, that turned into y equals negative 5 force x plus 5 from the last problem, and the bottom equation turned into y equals, and I'm just looking at the last problem. So if you want to see how I solve for these, you can look back at number 13. So we're looking at the y-intercept positive 5, and a y-intercept of negative 10. Which one has a larger y-intercept? A larger, bigger number would be the top one. 5 is bigger than negative 10. 5 is greater than negative 10. All right, number 15, we're going to graph using the x and y intercepts. So I got to find the x and y intercepts. X-intercept, set the y equal to 0. 5x plus 2 times 0 minus equals negative 6. We have 5x equals negative 6 divided by 5. And we get the x is going to equal negative 6/5, which if you convert that to a decimal is negative 1.2. So on our x-axis, we are going to go down to 1, negative 1. Negative 2 is going to be a little over negative 1. So somewhere in there is going to be where x-intercept. Now we'll look for our y-intercept. So to find the y-intercept, you have to set x equal to 0. And we're going to 5 times 0 is 0, plus 2y is 2y, divide by 2. And our y-intercept is at negative 3. So we're going to go on our y-axis down to negative 3. And now draw our line. You just need 2 points to graph. And there we go. Number 16, do the exact, graph the following function shifted up 3 units. So I need to get it into a form that, well, you either can solve for x and y intercepts, graph it that way. I'm actually going to graph it using, I'm going to get the equation into slope intercept form. So I wanted to get it in y equals mx plus b. That's the easiest way to solve, I think, and it's a lot of times the fastest. So I'm going to subtract 4x. I'm going to put the x term first. So negative 4x, and the 10 is a negative, so minus 10. And then I'm going to divide by 2 on every term. Anytime you multiply or divide, do it to every term in the problem. Negative 4 divided by 2 is negative 2. And negative 10 divided by 2 is negative 5. My y-intercept is negative 5. So I'm going to go down to negative 5, put a coordinate, and then I'm going to use the slope, negative 2 over 1. I'm going to go down 2 and right 1. Now I'm off the graph, and I don't like that. So instead of going down 2 and right 1, I'm going to go up 2 and left 1. Up 2, left 1, up 2, left 1. And you get nice coordinates that are on the graph. And you see my point that I had off the graph is not even close to where it should be. Oh, and I got to shift it up 3 units. Let's actually do what it asks. The problem asks to shift up 3 units. So I got to shift every point up 3, up 3, up 3, up 3, up 3. All right, that's the only ones that I can do. There we go. Now if you were to find the equation for this, it'd be y equals, the slope stayed the same, and the y-intercept it changed to negative 2. So that would be the equation for that graph. All right, number 17, we need a graph y equals. So we're going to do the exact same thing as we actually just did. Graph it as if it's y equals. It's 3x. We don't know the y-intercept. Well, that's 0. Y-intercept 0. It's going to be 3 over 1. So up 3, right 1. Up 3, right 1. We could also go down 3 and left 1. It keeps on the same line. Oh, I went to a solid line. Luckily, it is a solid line because equal to, that means solid. Equal to, and then greater than symbol. Greater means shade above. So this is greater than. This is above the line. And if it was a less than, it would be over on the right side. So greater than, shade above. So we're just shading above. Any coordinate in that shaded area or on the line is a solution. All right, number 18. Let's solve for y. Anytime you multiply or divide by a negative, you do have to be careful that you have to switch the inequality. Well, we divided by a positive 2, so it does not switch the inequality. Now we have a y-intercept of negative 5 over 2. Negative 5 over 2. So y-intercept negative 5 over 2. Let's convert that to a decimal so that we can put it on the graph. That's negative 2.5, which is in between negative 2 and negative 3. And then we're going to go up 2, 1. Let me do this. Up 1, 2. Because our slope is 2 over 1. And then we're going to go right 1. So it lies in between. So go up 1, 2, over to right 1. Up 1, 2, right 1. Up 2, right 1. It is not equal to, so we do not need a solid line. It's going to be a dashed line because it's just less than, not equal to. So dashed line. And then it's a less than. Less than would be below the line. So this would be, if it was greater than, it'd be above. So less than, I'm going to shade below. All right, next we're going to graph x is less than 4y minus 5. Well, I need to solve for y. So I'm going to add 5, and I get y by itself. It did not switch to any multiplier, divide by negative, so we got divide by 4, divide by 4. It'd be x divided by 4 plus 5/4 equals, nope, not equals, less than y. We divided by a positive, so it does not switch. If I want to move this around so it looks more like what I want, it's like if you could take the whole, everything you see there and flip it all the way around, the y, you notice that it's opens up towards the y, the inequality, so it's got to be switched around to greater than, x divided by 4. There's a number in front of the x is a 1. And then 5/4. So we're going to graph 5/4. So the y-intercept is 5/4, which is 1.25. If you check on calculator. And then our slope is up 1 and right 4. We can go down 1 and left 4. And then our graph is dashed, not equal to, and greater than side is always above, less than is always below. So graphing this, we're going to be greater than. So that's where I'm going to shade. All right, number 20. We have 2y. Why is it? Isn't this the same problem as? Yeah, it is. Oh, it's the same graph. I'm going to change it to a -2 just to change it up. We're going to divide by -2. We divide it by a negative, so that switches inequality from less than to greater than. It becomes a -2x plus 5/2, because a negative divided by negative is positive. So we're going to go up 5.5, and we're going to go down 2 and right 1, down 2, right 1. Up 2 and left 1, just because it's not equal to, so it's a dashed line. If we're looking at what's greater than, or this would be the greater than, that's above the line, and less than is below the line. So greater than, this is a greater than symbol, so we're going to shade above. All right. Now to test if a coordinate is a solution, pretty simple. Substitute x and y into the equation. So 2 greater than 3 times x, so 3 times -1 plus 5. 2 is greater than, that's -3 plus 5. 2 is greater than 2. No, that is not true. So -1, 2 is not a solution. All right, let's check if 4 to 0 is a solution. So it's 3 times 4 minus 2 times 0. 3 times 4 is 12, minus 2 times 0 is 0. What? 12 is less than or equal to 5. No, that is, so 4 to 0 is not a solution, because 12 is not less than 5. I think that's it. All right.